Hi all, I am Luca Manzoni, the will-be coordinator of the new master degree in scientific and data-intensive computing offered by the University of Trieste and other institutions in the area of Trieste, in particular the CISA, the other University of Trieste, the International Center for Theoretical Physics, the National Institute for Oceanography and Experimental Geophysics, ISS Spike, and the National Institutes of Astrophysics. So, what is this degree about? Well, this degree is about the convergence of many different fields and techniques that are shaping the future of science, particularly the old and good scientific computing for the simulation and forecasting of physical phenomena, the emergence of faster and faster computers and high-performance computing systems that allows to perform more the simulations in even more details, the new results in quantum computing that allows for a new, different kind of computing, the emergence of a large amount of data collected in the physical sciences, in oceanography, in mechanics, in any area, particularly of the human endeavor for new knowledge, and of machine learning, which is then a new field that is getting more and more traction every day and is influencing all the other fields, in particular the intersection within all those fields will produce a new kind of science, a new science, a new scientific methods making use of the computational devices, computational techniques that will need a new generation of experts. Which experts? The experts in scientific and data-intensive computers. So we decided to create this new master degree to tackle the future of science. So what's next? Well, in the last few years, there's been a lot of movement in science in the new scientific methods. So the use, for example, of supercomputing and machine learning techniques in many fields. Very near airport for the American Department of Energy on the use of artificial intelligence and machine learning for science and how this will influence the scientific methods in the next years and how they will emerge in what's called scientific machine learning, in creating a mix between new techniques and old techniques in scientific computing. And the new and difficult problems in understanding the climate and how to save also our Earth will need the use of more complex and powerful techniques in scientific computing. So I talked a lot about scientific computing. What's scientific computing? Well, let's define it as what a computational scientist, a person doing scientific computing does. They are a person that apply high-performance computing for the advancement of the state-of-the-art in science. This science can be physics, chemistry, biology, ecology, oceanography, engineering. More or less every scientific field benefits from this, let's say, third modality of science. The first one being theory, the second being the experimental, and the third one is the computational aspect of science. This is a very well-established field with the simulation engine from the fluid dynamics simulation of the ecology, simulation of, for example, the stress in metals, and so on. practically every modern scientific research and engineering work requires some kind of scientific computing. And scientific computing, as I said, is changing fast with the integration of machine learning techniques to speed up every possible simulation. But scientific computing will be nothing without the computers that can run it. And what are they? Well, they are generally supercomputer, or more in general, high performance computing. And performance computing is changing. In particular, we see that the trends for the future are exascale computing, that is even faster supercomputers, high performance computing with a focus on artificial intelligence and machine learning. Most supercomputers that were inaugurated recently have a significant part of their power dedicated to accelerators for AI and machine learning. And high performance computing will also need the new quantum computers that are getting started now, after a lot of years only in the theory. And in fact, Italy is on the forefront of high performance computing with the supercomputer Leonardo recently inaugurated, which is the one of the fastest in the world and one of the fastest in Europe. And as I said, quantum computing is one of the big trends in high performance computing, and the European Union is investing a lot in quantum computing. In particular, in the initiative, the flagship initiative for quantum computing, the European Union plans to have multiple sites with quantum computer research in quantum computing and investing a lot of funds for this project, which will be on the same scale a project like the Human Genome Project. So Europe and the world are investing a lot in quantum computing, and we are investing in forming new students that can benefit and can use these new quantum computers. And across all of this, there is also the presence of digital twins. Digital twins is something new, which is the union, can be created by the union of scientific computing, high performance computing, and machine learning. Digital twins are digital replica of real world systems that can be used in a lot of cases instead of the real world system to actually perform tests, simulation, what if scenario, testing, monitoring, and so on. As Forbes said a few years ago, digital twins are a business imperative. That is, practically all companies will need to have digital twin, digital replica of the real world phenomenon, real world objects, to be able to compete in the world. So experts able to create digital twins will be needed and are needed now. And Europe is investing a lot into this decade, which is the decade of the oceans and waters, on creating digital twins of the ocean, a replica of the, for example, of the seas and the oceans, and that can be used to forecast, to guide scenarios, to guide the development of new sustainable economies. And in fact, even the University of Trieste is at the forefront with one of the biggest projects for the creation of a digital twin of the Adriatic Sea. So we want also to move this creation of digital twins, which requires skills and knowledge that is actually at the state of the art, also to students that will be able in the future to move this knowledge, these techniques into multiple industries and research centers. So that's why we created this new master degree as split between the old and successful master degree in data science and scientific computing into two master degrees, one focused on data science and artificial intelligence, and this one focused on scientific and data intensive computing. I would say two twins degrees, not digital twins, but in this case, real twins that complement each other, with this degree having the focus on, say, the most practical applications of these new techniques into multiple areas. In fact, we have multiple degrees in multiple curricula part of this degree, one in computational modeling and digital twins, with 5 subcurricula, all with different focuses. And this curriculum will focus more on the modeling part, how to model a real-world phenomenon with connection with physics, oceanography, and so on, and how to build digital twins. So scientific computing and high-performance computing and machine learning, all for building the next generation of scientific computings and digital twins. A curriculum in high-performance computing and data engineering with 2 sub-curriculum, one will focus on high-performance computing and one on data engineering, more on how to build fast, scalable, and systems, how to build code that is able to run efficiently, and how to manage the large amount of data that those systems requires. And one curriculum focusing on quantum computing, quantum algorithm, quantum machine learning, and all the areas related to build the next generation of scientists expert in quantum computing. The advantage of this, the presence of this, that many curriculum, sub-curriculum, is that you have a lot of flexibility, and also we decided to actually have the possibility to choose usually between a basic and advanced course mainly for the first year. So, for example, if you have already done a course on algorithm, you can go to a course on advanced algorithm for scientific computing. And so that you can start at your level and then continue with that. And also a lot of specialization with many topic-specific courses offered by not only by the University of Trieste, but by the many institutions collaborating in the creation of this master degree. And now focusing on different courses and the different sub-curriculum. In the curriculum on computational modeling and digital twins, we have different focuses on either industrial computational mechanics or focusing on modeling the ocean and the climate, or moving toward what's in the sky, that is work on computational cosmology, and then working instead of modeling physical system and chemical systems. And also one sub-curriculum on discrete modeling that is not continuous systems, but mainly discrete systems that could be, for example, crowds and so on. So modeling things that are fundamentally discrete units. As for the courses, we have a first choice between an advanced programmer performance cloud computing or software development method performance computing cloud computing, depending on your background in programming. A course which is probability statistics specific for scientific computing, and the first choice, a numerical analysis, modeling using stochastic systems, or optimization using meta-heuristics techniques. Then a choice between 3 machine learning courses, depending if you have already done an introductory course of machine learning. In that case, you can select by probabilistic or machine learning reinforcement learning. In any case, you will study deep learning, which, as we said, is part of the machine learning needed for the new generation of scientific computing. And then numerical analysis, so between numerical analysis, stochastic model and simulation, and algorithm for scientific computing, and as I said, advanced algorithm for scientific computing, depending, as I said, on your background, so that you can have a curriculum that is a study plan that is actually tailored to your experience. High-performance computing and data engineering, still the choice for the first courses, and then some courses in common, but others that are specific for high-performance computing, like advanced and high-performance computing and data management. And for quantum computing, again, some courses in common, and a lot of focus on quantum information theory, and specifically in the quantum mechanics in computing. And in the second year, for all curriculum, you have the choices across many topic-specific courses, so that you can actually tailor this degree to a specific topic. So, and elective courses, as I said, we also have the choice for elective courses, and a big part of the second year will be dedicated to an internship and a thesis. An internship, which is 12 credits, and the thesis, which is 24 credits. They can be different, so you can have, for example, an internship in a research center or a company, or even internal at the university research lab, and the thesis, which is again with the company or a research center, with 2 supervisors, one internal in the university and one in the company or in the research lab, or even another university. And as you can see, for the number of credits, these thesis and internships takes a big part of the second year, and can even be combined together with an even bigger research project. For some information, the lectures will be made at the University of Trieste, and they will be in presence and recorded, but we want to focus mainly for with an experience for people that are here attending the lectures in Trieste. The experience for the master degree is not only following the lectures, but also interacting with the faculty and with other students to find more comprehensive experience in this master degree, to have a more comprehensive experience, to have a more, and also to know new people, to learn how to do research in this area of scientific and data-intensive computing. What about the admission? Well, there are some requirements. Clearly, is with a master degree, which is so specialized, you need a lot of previous experience to be able to actually follow successfully the master degree. So a total of 60 credits between mathematics, computer science, engineering, physics, statistics, economy, finance, chemistry, genetics and molecular biology, and so on. At least 21 mathematics or mathematics for economy, and 6 in computer science or computer engineering. So To enroll, you need a strong background in mathematics and computer and science engineering in general. There are 65 positions, of which 15 are assigned for non-EU students, and the selection procedure is in 2 phases. The first is open now and will close in May, and the second will open between July and August. And to participate to this selection procedure, you will be submitted your CV that will be evaluated. You will be admitted to an interview in the beginning of June for the first application phase, and in September for the second. The application is in common with the other master degree, which is data science and artificial intelligence, and with a common interview. You will need to specify your preference, that is, you prefer to enroll in one or the other master degree during the application. There will be a very strict agreement to enroll once you are selected, and if one does not enroll, but you are still eligible because there are only a limited number of places, you will still you can still be contacted if someone will not enroll. If you are working students, there are part-time programs available. In any case, as I said before, lectures are recorded and possibly, not in all cases, streamed, but the exams will be in presence. So I hope to see you soon in this master degree in scientific and intensive computing. And now I leave the stage to one student of the current data science and scientific computing master degree, which has a focus on the scientific computing part. So the floor is yours, Guillermo, and bye.
Hi all, I am Guillermo Padula, a master student at the degree of data science and scientific computing. I'm doing a custom curriculum about probabilistic inference and simulation. I did my bachelor degree in mathematics at the University of Florence. I gave chosen this course because the mathematics degree was too much theoretical for me, and here I found a lot of very good institutions and a lot of applications that I like.